Hi, my name's Claire and today's lesson is about understanding equalisation. So to learn how equalisation works, we need to understand Boyles Law and how it affects us as divers. Boyles Law states that the volume of a gas is inversely proportional to its pressure when temperature is constant. The formula for this is P1 by V1 equals P2 by V2. But what does that actually mean? Let's break this down. P represents pressure and V represents volume. P1 and V1 represent the initial pressure and volume of gas. So here we have the bottle on the left hand side, which is full of air on the surface. P2 and V2 represent the final pressure and volume after a change. On the left you can see the bottle under the water is squashed. This is due to the pressure under the water causing the volume inside the bottle to decrease. So what effect does this have on divers? As scuba divers, we have a number of airspaces that will be affected by the increase in pressure as we descend, which we need to take into consideration. Now we can use Boyles' law to work out what the new volume will be at certain depths using the calculation. If we say a diver's lungs have a capacity of 10 litres of air on the surface, which is 1 atmosphere of pressure, the diver then descends to 10 metres. The calculation will look like this. We're working out the final volume. We have the rest of the figures, 1 atmosphere of pressure, of which the lung capacity is 10 litres. We now need to divide 10 by the final pressure, which is 2 atmospheres. So the answer to the question is 5 litres. What about if the same diver dived down to 20 metres, starting with the same lung capacity? The calculation stays exactly the same, apart from we are now changing it to 3 atmospheres of pressure. So we are now dividing 10 by 3, which is 3.33 litres. So the diver's lung capacity has gone from 10 litres to 3.33 litres. So what else is affected by Boyles' law? Your BCD is an airspace, so as we're descending, the volume of this will also decrease as you descend. This is why, once you're a couple of metres under the water, you will feel yourself descending without doing anything. This is because the airspace is decreased enough for the gravitational force to be greater than the buoyant force. Please see our video on Archimedes' principle for more on this. This is why, as you descend, you need to add a little bit of air in every now and again to compensate for the volume of air decreasing. Your ears and sinuses. This is why it is so important to equalise when you descend. You have an airspace inside your middle ear. As you descend, the volume decreases in your middle ear and sinuses, causing a squeeze. To compensate for this is where we need to equalise, allowing that pressure to return to normal using the air that we're breathing, which in turn stops your ears from getting injured. This is also why it's important not to take anti-congestion medication before diving, as it can stop working mid-dive and stop you from being able to equalise this airspace, which when descending will just end your dive early as you'll need to surface. But if your problem starts when you're ascending, you get something called a reverse squeeze, where the airspace expands where it cannot release, making it hard to ascend without injuring yourself. Your cylinder. Have you ever thought about how much quicker you breathe through your air when you dive deeper than you would if you were at shallow? This is due to the pressure increasing again as we descend, so the volume of air inside your cylinder. Your mask. This is why when you're on the surface, the mask shouldn't be really tight on your face, because as soon as you start descending, the volume will start to decrease. This is where you find people who get what's called a mask squeeze. So we need to equalise the mask while we're descending by putting a little bit of air as and when required. Time for a quick recap. So today we've gone over airspaces and equalising, Boyles' law, how it affects us on dives, Boyles Law Calculations, what else is affected by Boyles' law, and safety considerations. I hope this video has been helpful. Please don't forget to hit the like button and subscribe to help support us in making more of these videos.